Hello students. Today we discuss about trigonometric identities. First of all, we look the reciprocal identities. Reciprocal identities we are learning from starting onwards. That is, cosecant x is the reciprocal of sin x, so we can write it as 1 by sin x. And secant x is the reciprocal of cos x, so we can write it as 1 by cos x. Cot x is reciprocal of tan x, so that we can write it as 1 by tan x. Now, we discuss about the quotient identities. Quotient identities, tan x can be written as sin x by cos x, and cot x can be written as cos x by sin x. These we call as quotient identities. Now, let us discuss about Pythagorean trigonometric identities. That is the new to learn it. So, take a right angle triangle ABC. If you take this right angle triangle ABC, angle A and angle C are acute angles and B is the right angle. By as per Pythagoras statement, hypotenuse square. So here I will write the names. With respect to A, I would like to speak. So then this is the adjacent side. With respect to A, I am speaking. So this is opposite side and this is hypotenuse. Okay, this is hypotenuse. Now we'll proceed. So if you take this one, dividing both sides with the AC square, then what will happen? AB square by AC square plus BC square by AC square is equal to AC square by AC square. Now AB square by AC square can be written as AB by AC whole square plus BC square by AC square can be written as BC by AC whole square. That is equal to AC square by AC square. Next, that is equal to AC by AC whole square. Now, AB by AC, AB means what side? Adjacent side by hypotenuse. That means we can write it as cos A whole square. BC by AC, this is what? Opposite side. And AC is what? Hypotenuse square. So we can write it as sin A whole square. AC by AC, here AC and AC get cancelled, we'll get 1 square. That is 1. Cos A whole square will be written as cos square A plus sin square A will be written as sin A whole square will be written as sin square A is equal to 1. Therefore, the first trigonometric identity is cos square A plus sin square A is equal to 1, or otherwise we can call it as sin square A plus cos square A is equal to 1. Next, let us look the second one. If we take the equation 1, again, AB square by here, AC square is equal to AB square plus BC square. Beforely we divided both sides by AC. Now we divide both sides by AB square. AB square by AB square is equal to BC square by AB square is equal to AC square by AB square. Now, AB square by AB square can be written as AB by AB whole square plus BC by BC square by AB square can be written as BC by AB whole square is equal to AC square by AB square can be written as AC by AB whole square. Now, here AB get cancelled. AB get cancelled, that is 1 square means 1, and BC by AB, here BC is the opposite side and AB is the adjacent side, means opposite by adjacent is nothing but tan, so tan square A, and AC by AB, AC is hypotenuse and AB is adjacent side, so it is nothing but secant. So 1 plus C tan square A is equal to secant square A. Other is we can write it as secant square A minus tan square A. If you bring tan square to this side, plus becomes minus tan square A is equal to 1 is equal to 1. Okay. Now, this is the second trigonometric identity. Now we'll go to next one. Before we already divided the first equation with AC and AB. So that now we divide both sides with the BC square. If we divide it with BC square, AB square by BC square plus BC square by BC square is equal to AC square by BC square. So that AB by BC is nothing but AB by BC whole square. BC square by BC square is nothing but BC by BC whole square. AC by BC is nothing but AC by BC whole square. Here BC get cancelled, it is one square. So that AB by BC, here AB by BC. AB is the adjacent side and BC is the opposite side. So that adjacent by opposite is nothing but cot, and here it is 1, that is equal to AC. AC means it is hypotenuse. Hypotenuse by opposite side is nothing but cosecant square. Therefore, the third identity is cot square plus 1 is equal to cosecant square A. Otherwise, we can write it as cosecant cosecant square A minus cot square A. Cot square A is equal to 1. So this is the Pythagorean trigonometric identity 3. So if you look all the three at a time, here taking x, the three trigonometric identities are sin square x plus cos square x is equal to 1. Tan square x plus 1 is equal to secant square x. 1 plus cot square x is equal to cosecant square x. Here one statement is there. The only unique identity here is top one. Unique identity is one. The other two can be obtained using the top identity. By using this also we can get to this one. How can we get this? To get tan square, the first equation can be divide both sides by cos square. If you divide it by cos square, sin square by cos square is tan square. Cos square by cos square cancel and we'll get 1. And 1 by sin 1 by cos square is nothing but secant square x. Like that we can get the third one also. Next, variation of the identities. If you take the first identity, what is the first identity? Sine square x, sine square x plus cos square x is equal to 1. So from this we can write as if you bring sine square to this side, what will happen? Minus. So 1 minus sine square x is equal to cos square x. Otherwise, if you bring cos square x to this side, then 1 minus cos square x is equal to sine square x. We can create different variations of many of these identities by using arithmetic. Like this, we can change and we can write in many ways. So, here what we have to learn that all the facts, there are several basic trigonometric facts or identities which it is important to remember. The tan x is equal to sin x by cos x. And first Pythagorean trigonometric identity is sin square x plus cos square x is equal to 1. Alternately, we can change that cos square x is equal to 1 minus sin square x. Sin square x is equal to 1 minus cos square x. And moreover, sin x whole square can be written as sin square x. By using all these identities, we can find the trigonometric other trigonometric ratios also. Here you look find tan x if sin x is equal to 2 by 3. The old method is we will draw a triangle and find the third side. From that we can find the tan x. In the new method using these identities, cos square x can be written as 1 minus sin square x. So that sin x is given 2 by 3. Substitute here, we'll get 4 by 9. After getting LCM, we'll get 5 by 9. Here, we want tan x. That means cos x is equal to how much here? Root 5 by root 9 means 3. So tan x is nothing but it is ratio of it's division of sin x by cos x. So the 2 by 3 divided by root 5 by 3. And 3 get cancelled, will get 2 by root 5. So we'll do quick revision. Quotient identities are what? Tan theta is equal to sin theta by cos theta and cot theta is equal to cos theta by sin theta. These we call as quotient identities. What are reciprocal identities? Cosecant is equal to 1 by sin theta. Secant theta is equal to 1 by cos theta. Cot theta is equal to 1 by tan theta. Or otherwise, sin theta is equal to 1 by cos theta. Cos theta is equal to 1 by secant theta. Tan theta is equal to 1 by cot theta. These are the quotient identities and reciprocal identities. Now, Pythagorean identities are sin square theta plus cos square theta is equal to 1. Second one is 1 plus tan square theta is equal to secant square theta. Cot square theta plus 1 is equal to cosecant square theta. Using these identities, we can do so many problems. So, let us do the problems. Thank you, one and all.